This is a numerical based on the nodal analysis where we have to determine the first voltage drop across the 4 ohm, means here the voltage drop across this branch, and the given one is that this is V1 and this is V2 point. Okay, and the second point is current through J2 and minus J2, means current through this two branches. Okay, but the method is what? The method is nodal analysis. Okay, as I said earlier, uh, before applying the nodal analysis, what we want for the simplification, we want a current sources. Okay, but in given numerical, which are the sources are present? The present is voltage source is present, so convert this voltage sources into its equivalent current sources. Okay, solve. So now we will convert this. So equivalent current source with respect to this branch 5 as it is, this J2 as it is, then this is 4, this is capacitor minus J2 with the impedance 2. Here we have a current source. This current source, it is equal to 50 at an angle 0 degree upon 5. How much? 10 at an angle 0 degree, that is nothing but the 10 ampere. The direction is, it is a plus minus, so direction will be upward. Similarly for this side, here we have 50 at an angle 90 degree upon 2, so it would be 25 at an angle 90 degree, and the direction is upward because it is a plus minus. Clear? Now we have to label the nodes. How many nodes are present here? Okay, the given one is here, this is a second node. Always we have to consider one reference node. Okay, the last node will be your reference node where all the points are connected, all the branches are connected. Okay, this is 1 2 3. How many nodes are there? Here we have a 3 nodes. Okay, now write down, consider node 3 as an reference node, that means V3 equal to 0 volt. Okay, this is for the reference term. Now apply KCL at node 1. Okay, KCL at node. Now in this point at node 1, see how many branches are connected? This branch, this branch, this and this. How many? 4 branches are here, so the 4 values will be here. KCL means current. Okay, we want the value of current. So current, since we know current equal to what? Voltage upon the resistance. Using this, see, current is 10. Okay, minus for this 5 में से कितना करंट फ्लो हो रहा है? How we can decide? Voltage for this. Okay, this is connected in between these 2 points, that is we can say V1 minus V3 upon 5. Clear? Similarly for this, it is connected between this, so minus V1 minus V3 upon how much? Plus J2. Now this branch minus V1 minus V2 upon what? 4 equal to 0. So now in this equation we will put the value, that is V3 equal to 0. Now put the value, so we get the equation 10 minus v1 upon 5 minus v1 upon j2 minus v1 minus v2 upon 4 equal to 0. In the same way, put the current source on left hand side and all the drops on right hand side. So 10 equal to v1 upon 5 plus v1 upon j2, open the bracket, so v1 by 4 minus v2 by 4. So 10 equal to, take the v1 common, 1 by 5 plus 1 by j2 plus 1 by 4 minus v2 by 4. This is the equation number 1. Okay, now clear, this is the equation. So now apply the KCL, at node 2. Okay, so node 2, starting with this, how many current source? Only one, that is 25 at an angle 90 degree. This branch is completed. Now going for this branch 2. So equation क्या आएगा? v2 minus v3 upon 2 minus, after this branch j2, v2 minus v3 upon minus j2. Okay, after this branch minus v2 upon v1. Why v2 upon v1? Because we are applying the KCL at node 2. Okay, so dominating one is node 2. So v2 minus v1 equal to 0. Okay, so now put the value of v3. So it would be 25 at an angle 90 degree minus v2 upon 2 minus v2 upon minus j2. Okay, I am keeping the minus j2 same. Okay, minus of v2 minus v1 upon 4. Similar way, take the keep the current source on left hand side and all the other sources on right hand side. So it would be 25 at an angle 90 degree equal to how much? v2 upon 2 plus v2 upon minus j2 plus v2 upon 4 minus v1 upon 4. Now take the common, so it would be 25 at an angle 90 degree equal to v2, कॉमन लेते हैं 1/2, इसका मैं माइनस यहाँ ले लेती हूँ, माइनस 1/j2 प्लस 1/4. okay, minus 1/4 v1, that is the equation number 2. Now we have the equation number 1 and the equation number 2. Now write down, arrange equation number 1 and 2 in a matrix form as z v equal to I. We have to arrange in this matter. Okay, so arrange it. Now after arranging the equation in matrix form, here we got this matrix equation. Now in a similar way, we have to determine the values. So using a Cramer's rule, we can say v1 equal to del 1 by del and v2 equal to del 2 by del. So first we have to determine the values v1 and v2. Okay, in a similar way. Okay, like in mesh analysis, v1 equal to del 1 by del, v2 equal to del 2 by del. So we know the del is what? The impedance matrix. This is Okay, solve this impedance matrix and tell me the answer. सीधा ड्यूरिंग द सॉल्यूशन अगर हम ये कंसिडर करते इक्वेशन क्या आएगा 1/5 प्लस J2 प्लस 1/4 मल्टीप्लाइड बाय 1/2 माइनस 1/J2 प्लस 1/4 ब्रैकेट कंप्लीट माइनस ऑफ -1/4 -1/4. This is your equation. Tell me the answer of this. So this is the answer of del. Okay, after solution कैल्शियम में सेम वे में पुट करो जैसे हमने यहाँ लिखा है, तो यू विल गेट द आंसर 0.5460 एट एन एंगल -15.9453. Okay, now we have to solve the del 1. Okay, for the del 1 what is the rule? We have to replace the column 1 by the current matrix. So replace this, so it would be here 10 upon 25 at an angle 90 degree. Now solve this matrix and tell me the value of del 1. The equation would be 10 into 1/2 1 minus J2 1 plus 4 bracket complete minus of minus 1/4 into 25 at an angle 90 degree bracket complete. Tell me the del 1. Here you can put one more bracket if you want. So this is the answer of del 1, 13.5208 at an angle 56.3099. Okay, now we have to determine what? We have to determine the value of del 2, and for the del 2 what we have to do? We have to replace this column 2 by the current matrix. Okay, so remove this. So here we get 10 25 at an angle 90 degree. Solve. So del 2 equation, what will be the equation of del 2? Del 2 equals to 25 at an angle 90 degree 1/5 plus 1/J2 plus 1/4 bracket complete minus of 10 into minus 1/4. This is the answer of del 2. So this is the answer of del 2, where del 2 is equal to 18.75 at an angle 36.8698. So now we know the value of del 1, del 2. So easily we can determine the V1, that is del 1 by del, and the value of V2, that is del 2 by del. Now put the values and tell me the answer. Okay, after using the values of del 1 and del 2, using this equation, finally we get this values V1 and V2. Okay, now in question were asked that the first term is what? We have to determine the voltage drop across the 4 ohm resistor. Okay, across the 4 ohm. 4 ohm is what? Here the voltage drop. Okay, voltage drop means the voltage difference between V1 and V2. Okay, now from this equation we can also say V1 minus V2 also, and the V2 minus V1. Which equation to be considered? Depend on what? The values of V1 and V2. Which value is more? V1 is more or V2 is more as compared to the magnitude? If we take the reference as magnitude, which value is more, V2 or V1? Yes, which is more? V2 is more. So we consider the equation V2 minus V1. Now put the value and tell me the answer. V2 minus V8. So we got the answer what? 13.7362 at an angle 15.9453 volt. This is the voltage. So this is the answer, that is the voltage drop across the 4 ohm resistor V2 minus V1. Now the second term, what we have to determine the second part, the current through plus J2 and minus J2. So current through this plus J2 and minus J2, current through this branch plus J2, what will be the equation? Okay, here the reference point is also here. So current through, first we consider plus J2 equal to, what will be the equation? Voltage difference, this is a V3, voltage difference upon impedance, that is V1 minus V3 upon J2. Put the value, we know the value of V3 is 0. Now put and tell me the answer. The answer is 12.3816 at an angle 7448. So this is the answer, that 12.3816 at an angle minus 17.7448 ampere. This is the current through plus J2. Similarly, if I have to determine the current through minus J2, so the equation will be, tell me the equation. We have to consider this branch, so V2 minus V3 upon minus J2. Okay, now solve and tell me the answer. And 17 hmm 1703 at an angle 8151 ampere. This is the current through minus J2. Okay, the numerical is solved.